Welcome back. We're going to find the point of intersection of a line and a plane, and we're also going to find the line of intersection of two planes in this video. Two fairly simple algorithms. So you could imagine a plane and a line. You have a plane of some sort and a line. They're going to intersect at a point. It's quite possible if this line were in the plane, well, you have an infinite number of intersections, and that would actually show up in our solution. That's not the case here. Well, it's simply a matter of substitution here. X is t, so we put a t in here, a 2t, a t plus 1. If there were coefficients, you'd have to multiply, and we generate one equation, one unknown, for which we can solve for t. So we start with the plane equation, x plus y plus z equals 9. Substitute t plus 2t plus t plus 1 equals 9. 4t plus 1 equals 9. Solve, we get t equals 2. Okay, that tells us when the line intersects. It doesn't tell us where. So we're simply going to plug in here. X equals 2. Y equals 2 times 2, or 4, and z equals 2 plus 1, or 3. So this is where 2, 4, 3. You can do a visual check. 2, 4, 3 satisfies a plane equation. We're good there. And at t equals 2, plug in, we get 2, 4, 3. So it's definitely on the line in the plane. So now we have two planes. The planes will, several things can happen with planes. They can coincide. These are clearly not the same plane equations. They can be parallel and distinct. That's not the case here. We have a normal vector 1, 2, 1, a normal vector negative 1, negative 1, 1. If the planes were parallel, the normal vectors would be parallel. So these do intersect. And if you intersect two plane equations, you end up with something like this. There's the line of intersection. Here's what we're going to do. First of all, we're going to eliminate a variable. And so x plus 2y plus z equals 1, negative x minus y plus z equals 3. You can eliminate a variable by adding the equations up. If need be, and x eliminates in this case, if we couldn't eliminate x, you could double this equation to eliminate y, or you could subtract to eliminate z. It doesn't matter. Pick your favorite variable, eliminate it. We add, this adds up to 0, 2y minus y is y, plus 2z equals 4. Now we're going to parameterize one variable. In this case, we're going to parameterize z because it's easiest. So we're going to let z equal t. Substitute y plus 2t equals 4. Y equals negative 2t plus 4. Okay, so far we have 2/3 of our solution. How do we find the last one? Well, you can substitute into either one of these plane equations. Probably easiest to do this. You can start with x plus 2y plus z equals 1. And substitute x plus 2 times negative 2t plus 4 plus z is equal to t equals 1. And x minus 4t plus 8 plus t equals 1. And this is negative 3t. Move it over here, we get 3t. Move the 8 over here, minus 7. And there's our answer. There's our line equation, a parametric form of a line equation. That's normally what you end up with. X equals, y equals, z equals. We could check this, and actually the parallel vector in this case is 3, negative 2, 2. You want to check to make sure that's orthogonal to the parallel vector here, or the normal vector here and the normal vector here. The normal vector here is 1, 2, 1. The normal vector here is -1, -1, 1. You can just do a visual check. If we dot these together, 3 minus 6 is -3, or 3 minus 4 is -1. Wait a second. 3 minus 4 is -1. -1 plus 2 is 1. That doesn't work out. 1, 2, 1, -1, -1, 1. Okay. 3, -2. Oh, I chose the wrong one. This is a 1 here. Sorry about that. Okay, the z coefficient is 1, my mistake. 3 minus 4 is -1. -1 plus 1 is 1. We're good. Look at this vector over here. -3 plus 2 is -1. -1 plus 1 is 0. So that is the geometry here. We mentioned before you can take this these two plane equations. This vector right here is 3, -2, 1. It's parallel to this line of intersection, and it's going to be perpendicular to a normal vector. A vector normal to this plane, normal to this plane. So it is what it is. We did proper work. Okay, we'll be back with another video on finding the point of intersection of two lines. We're going to do that in a separate short video.